Hey guys, welcome back to the channel and this new tutorial of Multilingual NLP series. And in the last video, we learned about like how we can train our token classification model using stochastic gradient descent. In this tutorial, we will continue and learn about mini batch gradient descent for token classification. Okay, so let us dive in and see how we can do that. So um So for mini batch gradient descent, we need to have a padding mechanism. Okay. For example, here we have two examples. The quick brown fox jumps over the lazy dog and the fox jumps over the lazy dog. So, and the label corresponding we have here. So here the length is like when we run through it using a sentence transformer, we will get the embeddings like first one will be 10 cross 768 and the second one will be 8 cross 768. So for a batch uh, to pass through the neural network, they should be of the same size. So we need to make them to be of the same size. So the required embedding dimension should be like 10 cross 768 for each and every input sample in a particular batch. Okay. And here we need to add 2 cross 768 for the input embedding and two extra padded labels to the labels as well. Okay, so here you can see like for input embeddings we need to add 1 cross 768 for each padded tokens using a pad token id, which will be dependent on our tokenizer itself. And then for labels we need to add a pad id that we will specify in our label encoding part. Okay, so let us go to our PyCharm id and start coding. So here we have our PyCharm ID. So first let us add pad tokens. So let us add here like in our code base where we actually create label to ID dictionary. So we will simply initialize it with simply like say pad, and let us say it's 0, and let us add another one Ank, and let us say 1. So I will tell you why I added Ank. So far we have used here like label O for unknown tokens. Okay, instead of this it is the more standard or more practical way of using this Ank token. Okay, so that's why I added that. So let us do that as well. So now it is perfect in that sense. Okay, and let us go ahead and implement our batcher then. So for batcher, it is simply an iterator which actually implements iter method, and another one is next method. Okay, so let us create a class batcher and let us extend object, and let us define our init method. And what we need is we need data x, data y, and batch size. And what else do we need? We need pad id for tokens, and then pad id for labels, and also we need embedding dimension, and we need seed. So this will require to shuffle the data every time we complete an iteration over, so that makes it a bit more generalized for training specifically. Okay, so let us create self dot data x is equal to data x self dot data y is equal to data y self dot pad id is equal to pad id. Also let us say batch size before it. Self dot batch size is equal to batch size self dot pad id label is equal to pad id labels self dot embedding dimension is equal to embedding dimension. And now let us create indices. So let us say self dot indices is equal to, let us use numpy dot, or let us import it, range. So let us first, we need to have the number of samples. So let us say self dot num samples is equal to data x dot say 0. This will give us like how many samples we have in the training data. Now here we will pass it here. Okay, self dot num samples. Next, let us create a pointer like how much we already traversed data, and then also let us create a random state that we will use every time we reshuffle the data. Okay, so let us do that. Self dot ptr is equal to 0. Self dot rnd is equal to numpy dot random state, and let us pass seed here. So this will be consistent. Okay, so that's all for init method. Let us define our iterator. So simply we will return here self, and the main part is this next method. Okay, so next method will have two part. One which will check the condition, like if we already traverse all the data, so it will stop the iteration. And the next part we will process the batch and return tensors as a batch. Okay, so let us do that. If self dot ptr is greater than self dot num samples, okay, then what we need to do is we simply say self dot pointer is equal to 0 first thing, and then self dot, let us shuffle it. And what we will need to shuffle is shuffle the indices. Okay, and simply we say, and to stop the iteration we simply raise an exception here, and that is nothing but stop iteration. That's our first block. And then in else part we will extract a batch and then add those padded tokens for both embeddings as well as labels, and then return the batch for further training process. Okay, so let us do that. Let us say batch x is equal to self dot data x, and simply we will say self dot pointer, and let us simply slice it to self dot pointer plus self dot batch size. And let us do the same thing for y as well, which is nothing but labels. Okay, and let us increment the pointer. Self dot pointer plus is equal to self dot batch size. Now next we will need to add padding for both embedding as well as labels. So let us do that. So for that, first we need to find out the max length in that batch. Okay, so that we can simply do like, let us compute length of each and every sample. So we can simply say lengths is equal to len x for x in batch x. So this will give us length of all the samples in that particular batch, and then simply we will run max on that. That will give us maximum length of any particular token, any particular sample in that particular batch. Okay, so we will say max length batch, and we will simply call max on lengths. Okay, so first let us create padding for IDs. So let us call it paddings. And what we will do is we will create a torch tensor, and fill it with pad id. Okay, so let us do that. Torch dot full, and what we need is simply max length into self dot embedding dimension. Okay, and let us fill value is nothing but self dot pad id, and let us use dtype as a float. Okay, next let us create padded labels, and what we will do is we will simply create create a placeholder that will contain that will be filled with pads, label pads, and then we will simply fill the actual labels in whatever length actual it has. Okay, so let us say self dot pad id labels into numpy dot once. What we need is here simply we can pass max length batch, and we need the length of batch x. Let us say our batch y, it will be the batch size in that sense. And let us now iterate over our batch x and fill in the actual labels in this, and also add padding to the embeddings. Okay, so let us simply say for idx and embedding in enumerate, simply we can say batch x, and what we need here, we need current length is equal to embeddings dot shape 0, and now we can simply fill here the actual labels. Okay, so we can simply idx and simply say current length is equal to batch y idx. Okay, now let us find out like how many um padded padded embeddings we need to add in our token embeddings. Okay, so simply we can say, let us say num paddings is equal to max length batch minus current length. So this means we need to add these many pads to the word embeddings actually. Okay, as we have already converted the token embeddings to true word embedding, so we will call it word embeddings. Okay, and if num paddings is greater than 0, then what we need to do is we need to simply get how much we need to add, and that is nothing but, let us call it t is equal to paddings, and let us slice it. So what we need is we can simply multiply num paddings into self dot embedding dimension. Okay, and let us flatten our embeddings. So let us create all embedding here as a list, and what next we do is we simply flat our embeddings, so all embeddings will be a single list of float number simply. Okay, so what we need to do is simply we need to plus, and we can simply say e for e in embeddings. Okay, this will flatten the embeddings, and then simply we will add this t in that. Okay, so this way it will simply keep adding these pads after each and every samples, and it is simply a flat list, and then we need to convert it into toss tensor and simply reshape it. Okay, let us do that. So after loop we can simply say batch x final is equal to torch dot cat, and simply pass all embeddings, and we simply reshape it view. Okay, and what it needs is simply it needs length of batch x, and it needs max length batch, and it needs self dot embedding dimension. Okay, so this is our x already padded with pad tokens, and this is what we return. And also the labels, we need to convert them into long tensor, so we will simply pass it through that. So we can simply say batch y final is equal to torch dot long tensor padded labels, and that's what we return batch x final and batch y final, and that's our batcher actually. So this we can simply pass the batch size, and it will return us the batches of that particular size. Okay, and it will do the pre-processing, like it will add pads in both labels as well as in our embeddings. Okay, so let us use it. So let us create an object using the batcher and use it on our training. So let us here. So we need pad id for token as well as label. So we can simply say pad id is equal to, for tokenizer we can simply say tokenizer dot pad token id. This will give us some pad id for token, and then for label we can simply get it from the dictionary. Okay, so we have labels idx, we can simply get it with pad. Okay, now let us create our batcher. Batcher is equal to batcher. So here we need to convert our embedding as well as labels into a numpy array. Okay, so let us do that. So we can simply say numpy as array, and let us pass train embeddings, and let us say dtype is equal to object. So this is important here. Why? So if you will not pass object here, it will try to detect the object type, okay, data type, and then it will detect like it is a float value, and then it will throw an error because they are not of the same size. So when we pass it an object type, it will be simply a list of pointers instead of a condensed or dense list of object values. Okay, that's why this is important to pass here object type, data type as an object. Okay, so remember when you have to create a numpy array with different length, you need to pass d type as an object because it will create simply a array of pointers. Okay, and let us next we need to pass the same way numpy dot as array labels. Okay, the same thing we need to do here as well. We need to say it is an object type, and next we need to pass batch size, let us say 32, and we need to pass pad id, and we have the pad id. We need to pass pad id label, We have the PID ID label. We need to pass embedding dimension. We have the embedding dimension. Okay. And that's our batcher. So let us replace it on our training loop. Simply we can say for batch in batcher, and we can simply say batch x batch y is equal to batch, and let us pass it to the model, and we don't need to convert because we already converted it, and use it here. Okay, and that's it. Now our code is using mini batch gradient descent instead of stochastic gradient descent. Okay, so let us spin and see the results. So we will train 30 epochs and it will be now quick. So let us run and see it. Okay, so the training has completed, and so it is more or less comparable to the results that we have seen from a stochastic gradient descent. So why it is important to use mini batch? So it actually generalizes the model better, and it simply avoids the overfitting in that sense. Also, it speeds up the training when we have a large amount of data to train the model. Okay, so I hope it is clear. If you have queries, ask in the comment section. I will try to answer them in there. And in the next video, we will talk about zero sort transfer for multilingual. Okay, so in specifically, we will train the model for, let us say, English, and test it in for German and French. So we will use final data that is there in various languages. So we will see in the next video. Okay, so thanks for watching. Bye for now. Take care. See you in the next.